a problem of matrix from POIQ of JEE Main. And here it is said that let P, a matrix is given, a matrix is given, and a relation Q, this is equal to P A P transpose, this is given. And if P transpose Q raised to the power 2007 into P, this is equal to a matrix which is given by ABC. Then we have to find the value of this. Four options are given, right? If we carefully analyze about the matrix P, it is clear that P is nothing but the orthogonal matrix. So we first know about orthogonal matrix. A matrix P is said to be orthogonal if P into P transpose, this is equal to I, or P transpose into P, this is equal to I, then this is orthogonal matrix, right? Now to test the orthogonality, we write here the matrix P, this is root 3 by 2 half minus half root 3 by 2, this is P, and P transpose is clearly given by root 3 by 2, this is half because this is row and this is column, this is minus half and this is root 3 by 2. And multiplying this matrix with this matrix, we get the result as this is 3 by 4, this is 1 by 4, so 3 plus 1 by 4, this is 1. And this is 0, this is 0, this is 1. Clear? So we get P into P transpose, this is equal to I. And for the orthogonal matrix, we know that P inverse, that is the inverse of P, this is equal to P transpose. This is an important property of orthogonal matrix. We use this property. Now from this relation, we get Q, this is equal to P A P transpose. So we get P inverse Q into P inverse whole transpose. This is given by P inverse P A P transpose P inverse whole transpose. We multiply this relation from left by P inverse and from right by P inverse transpose. So we get from here, this is P transpose P into A, and this is P inverse P whole transpose. We use here another property of matrix AB transpose. This is B transpose A transpose, right? And clearly P inverse, this is also P transpose for orthogonal matrix. And we put the value of this and this here. This is I A, this is I transpose, which is given by A, right? So we get the relation A, this is equal to P inverse Q, P inverse whole transpose. And we write here, this is P transpose Q and P transpose whole transpose, because P is orthogonal, so P inverse, this is equal to P transpose, and this relation gives P transpose Q and P, because P transpose whole transpose, this is P, right? Now we multiply A by A, then we get A into A, this is A square, which is given by, we put here the value of A, P transpose QP, and again we put value of A, P transpose QP. So this is P transpose Q, P transpose QP, and this gives P transpose Q, this is I, this is for the property of orthogonal matrix, into Q into P. So we get P transpose Q square P, Okay, so we get this relation A square, this is equal to P transpose Q square P. By similar argument, we get our result P transpose Q to the power 2007 into P. This is A to the power 2007. Right? Now, what is the value of A to the power 2007? Here A is this. If we multiply 1011 with again 1101, that is, we have to find the value of A square. Then we get that A square, this is equal to, clearly this is 1, this is 2, this is 0, this is 1. Okay. Similarly, if we find the value of AQ, then we get 1301. Okay. So A raised to the power 2007, this is nothing but 200701. Clear? And comparing this matrix with this, we get the value of A, this is 1. The value of B, this is 2007. Value of C, this is 0, and value of D, this is again 1. Right? Now putting the value of A here, this is 2 plus, this is 2007 minus, this is 0, and this is minus 4. So we get 2007 plus 2 minus 4, this is 2005. Okay? So we get our option C as the correct option. Very, very interesting problem. We use the property of orthogonal matrix. Right? Thank you for watching.